Let's quickly review the difference between the control plane and the data plane. The control plane is the logic that controls forwarding behavior. Examples of control plane functions include routing protocols, as well as logic for configuring network middle boxes. Now, a routing protocol might compute shortest paths over a topology, but ultimately the results of such computations must be installed in switches that actually do the forwarding. The forwarding table entries themselves, and specifically the actions associated with forwarding traffic, according to the control plane logic, is what constitutes the data plane. So examples of data plane function include forwarding packets at the IP layer and doing things like switching at layer 2. So to reiterate, routing protocol functions that compute the paths are control plane functions, whereas the act of actually taking a packet on an input port and forwarding it to an output port is a data plane function. So why is separating the data and control planes a good idea? The first reason is independent evolution and development. Thus, software control of the network can evolve independently of the network hardware. The second reason that separating data and control planes is a good idea is the opportunity to control the network behavior from a high-level software program. Controlling the network from a high-level program, in theory, allows network operators to debug and check network behavior more easily than in the status quo, where network behavior is determined by the distributed low-level configuration across hundreds of switches and routers. The separation of data and control provides opportunities for better network management in data centers by facilitating such network tasks as virtual machine migration to adapt to fluctuating network demands. In routing, the separation of data and control provides more control over decision logic. In enterprise networks, SDN provides the ability to write security applications, such as applications that manage network access control. In research networks, the separation of data and control effectively allows us to virtualize the network so that research networks and experimental protocols can coexist with production networks on the same underlying network hardware.